welcome to another session of our force systems. So, in the previous session, we have discussed uh, the definition of force and the types of forces involved, and also the units of forces. And we have gone through various types of forces in the previous sessions. So, let me give a brief recap of those. Force is an agent which changes or tends to change the direction of a body which is moving or which is at a rest. And this force is measured in terms of newtons. And the force characteristic of the force is defined by four things, four characters. The first one is magnitude, then point of application, next direction, and line of action. And the nature of force is either pull or push. And the force is mathematically mathematically taken as force is equal to mass into acceleration. Next, the force system of forces is nothing but a number of forces which are active at a given specified area, or you know uh, concentrated area. And so this system of forces can be further classified as coplanar forces and non-coplanar forces. Coplanar forces are those which are acting on a same plane, lying on the same plane. Non-coplanar forces are those which which are lying on a different plane. Further, coplanar forces are again divided into coplanar collinear forces, coplanar concurrent forces, coplanar parallel forces, and coplanar non-concurrent forces. And we have already discussed all those. Again, further, non-coplanar forces are divided into non-coplanar parallel forces, non-coplanar concurrent forces, non-coplanar non-concurrent forces. So today we'll describe what are the various techniques of analyzing the forces. So in this presentation, we are going to have a brief idea about resolution of forces. So resolution is nothing but division of a single force into two number of forces. So resolution of forces. Next, resultant of coplanar forces. Say if two number of forces are acting, then what would be a single force that will replace the effect of these two forces, that is resultant of forces. Next, so this resultant of forces can be described by three laws. Those are parallelogram law of forces, next triangle law of forces, and polygon law of forces. So these laws can be explained briefly in this presentation, and examples for these all laws are explained in this. So first, resolution of forces. So resolution of forces is nothing but division of a single force into two components is nothing but resolution of forces. Simply we can tell it as a single force is replaced by two or more forces having the same effect. So in this we can see a diagram. So F is a force which is denoted by the red color. So this force F, its effect can be divided into two components. One is Fx and the other one is Fy. So Fx is nothing but if theta is the angle made with the horizontal force F, then the horizontal component would be F cos theta and the vertical component would be F sin theta. So this force F is resolved into two components, that is F cos theta and F sin theta. So let us have some examples of resolution of forces. So here you can see a force of 400 newtons and which is pulled at an angle of 60 degrees. So here the magnitude of force is 400 newtons and the direction is given as it is um, it is moving in an angle of 60 degrees with the horizontal. So theta is 60 and F is 400. So according to resolution of forces, our formula would be Fx equal to F cos theta. So Fx equal to F cos theta. So it means 400 into cos theta. So cos 60 is nothing but 1 by 2. So Fx would be 200 newtons. And similarly, the vertical component would be F sine theta. Fy is equal to F sine theta. So 400 newtons into sine 60 degrees. It is 346 newtons. So in this way, we'll uh, resolve a single force that is 400 newtons into effectively two components, that is 200 newtons along the x-axis and 346 newtons along the y-axis. So this means that, so if it is applying a force of 400 newtons along 60 degrees of direction, then its effect would be 200 newtons along the horizontal axis and 346 newtons along the vertical axis. So one more uh, example. Say if a dog is tied with a chain. So if its owner is pulling it with some force of 60 newtons and the angle made by that chain with the horizontal is 40 degrees. Now if we resolve the 60 newtons of force which is acting at 40 degrees with the as the horizontal and vertical components. So as you know, F is equal to 60 newtons and theta is 40 newtons. So horizontal force would be F into cos theta. So 60 into cos 40. So that will give you an answer of 45.9 newtons. And if I take a vertical force, then it is F sine theta. So it is 60 into sine 40. It will give 38.6 newtons. So that is all resolution of forces. Next coming composition of force. So this is vice versa of resolution of force. Say if you are having a single force, so if you are having two or more forces, so you are replacing that single two or more forces with a single force which will have the same effect. So that is nothing but composition of forces. So combining many number of forces with different magnitudes and directions acting on a single plane or different planes or at a single point. So that is nothing but composition of forces. Or simply we can say that the replacement of two or more forces by a single force having the same effect is called composition of force. So this is nothing but the single force which is replacing all these forces is simply called as resultant. So that's what is nothing but resultant. So that's what we have discussed. So if a many number of forces are replaced by a single force, means if those are all combined together and they are replaced by a single force, both in magnitude and in effect, it is nothing but resultant force. The single force obtained by combining many forces of different magnitudes and directions to give the same effect as that of system of forces is called as resultant force. Next, so this resultant can be found by various laws explained. So out of those we have some laws such as parallelogram law of forces and triangle law of forces and polygon law of forces. So before that, so this can be parallelogram law of forces can be used if you are using two concurrent forces. So if you are having concurrent forces, you can make use of parallelogram law of forces. So prior to that, so let us speak something about collinear forces. So as you know, collinear forces are nothing but the forces which act on same line. Say if I take P and Q are the forces which are acting on a same line and both are in the same direction, then the resultant will be P plus Q. Okay? So if two forces, collinear forces are acting along the same direction, then the resultant will be P plus Q. Say if the two forces are acting along opposite direction, collinear forces are acting along the opposite directions, then the resultant will be P minus Q. So this is nothing but that is for collinear forces. Now if you take two concurrent forces, as you know concurrent forces are nothing but the two forces which pass through a common point. So for those forces the resultant may be obtained by using this parallelogram law of forces. So parallelogram law of forces, so it states that if two forces are acting at a point are represented in magnitude and direction by the adjacent sides of a parallelogram, then the diagonal passing through the point of intersection represents the resultant in both magnitude and direction. So let us take this slide. So according to the law, so it means that let OA be represented by a force P. Let OB be represented by the force Q. So here P and Q are passing through a common point, that is O, and these two are represented by the adjacent sides of a parallelogram OACB by OA and OB. So according to this parallelogram law, if PQ are the two adjacent sides, then the diagonal, that is OC, is nothing but the resultant. So, so let us take a simple calculation or derivation of this resultant. So here you can see that if I consider the triangle ACD, then as you know AC is Q. So if I join C and D are perpendicular, so O angle OBOA is equal to angle CAD. So let theta be the angle between the two forces. Now consider the triangle CAD, then AC is Q and angle theta is CAD. Now CD is equal to Q sine theta. Similarly, AD is equal to Q cos theta. Now I'll consider again right angle triangle OCD. So in that OC is the hypotenuse. So according to this right angle triangle, uh, the hypotenuse square should be equal to uh, OC square should be equal to OD square plus CD square. So OD is nothing but OA plus AD. So OA plus AD whole square. This is of the form A plus B whole square. So A square plus B square plus 2AB. So OA square plus AD square plus 2OA plus into AD plus CD square. So as you know, OA is represented by the force P. So P square plus Q square cos square theta plus 2PQ cos theta, since AD is Q cos theta. And we know CD is Q sin theta. So it is Q square sin square theta. So taking Q square common, you are left with sin square theta plus cos square theta. So that is equal to 1. So left over thing is P square plus Q square plus 2PQ cos theta. So as you know, OC is represented by resultant. So R is equal to under root P square plus Q square plus 2PQ cos theta. Now let alpha be the angle made by the resultant with the horizontal. So now if I take tan alpha of the triangle OCD, so tan alpha is opposite side by adjacent side. So opposite side is CD by adjacent side is OD. OD is again OA plus AD. So Q sin theta by P plus Q cos theta. So alpha is equal to tan inverse of Q sin theta by P plus Q cos theta. So therefore the resultant, the magnitude of the resultant can be found by the formula R is equal to under root P square plus Q square plus 2PQ cos theta, and the direction of the resultant can be taken off by making of an angle, that is alpha is equal to tan inverse of Q sin theta by P plus Q cos theta. And moreover, there will be some special cases like when P and Q are at right angle to each other. It means when theta is equal to 90 degrees. What happens? So R is equal to under root P square plus Q square plus 2PQ cos 90. So, so there cos 90 is simply 0. So 0 into something will be 0. The resultant will be under root of P square plus Q square. Again, the same if you apply in this also. So tan alpha is equal to Q sin 90 by P plus Q cos 90. So sin 90 is 1, cos 90 is 0. So leftover thing will be tan alpha would be is equal to Q by P. So theta will, alpha will be is equal to tan inverse of Q by P. Again, there will be some special cases like if P is equal to Q. It means when both the forces are equal. So if you substitute instead of Q also P, then it will be like R is equal to P square plus P square plus 2P into P cos theta. So P square plus P square is nothing but 2P square, again 2P square plus 2P square cos theta. If you take 2P square common, the leftover thing is under root of 2P square into 1 plus cos theta. So 1 plus cos theta can be written as 2 cos square theta by 2. So 2p square into 2 cos square theta by 2, you will get simply 2p cos theta by 2. Again, the tan theta would be p sin alpha by, so p sin theta by p plus p cos theta. So at the denominator, if you take p common, then 1 plus cos theta. So sin theta by 1 plus cos theta is again, so sin A can be written as 2 sin A by 2 cos A by 2. Right? 1 plus cos theta can be written as 2 cos square theta by 2. So if you can cancel the whole things, the leftover would be tan theta by 2. So if you are using equal forces, then the resultant will be 2t cos theta by 2, and the angle would be uh, alpha is equal to tan inverse of theta by 2. Now let us take an example of uh, for this problem. So if two forces of magnitude 50 kilonewtons and 80 kilonewtons are acting at a point with an angle of 60 degrees with each other. So here P is equal to 80 kilonewtons and Q is equal to 50 kilonewtons, say. And given angle means it is theta is equal to 60 degrees. Now what would be the resultant of force and the direction of the force? So according to parallelogram law, we know that R is equal to under root of P square plus Q square plus 2PQ cos theta. So under root of 80 square plus 50 square plus 2 into 80 into 50 into cos of 60 degrees. So on calculating the whole things, you will get 113.5 kilonewtons. So this is the resultant of these two forces. Next, and the angle would be, so as you know, alpha equal to tan inverse of tan inverse of q tan inverse of q sin theta by p plus q cos theta. So tan inverse of 50 sin 60 by 80 plus 50 cos 60. So that will give an angle of 22.5 degrees. So that is all for parallelogram law formula. So these are very simple. Simply they will be given by F1, F2 and the angle theta will be given. And you have to make use of both the formula and find magnitude and direction. And sometimes they'll give the resultant and they'll ask you to find one of the forces. Either F1 or F2 they'll give, and they will give the resultant and they'll make you to find the force, the missing force. Next, triangle law of forces. So triangle law of forces state that if two coplanar forces which are acting simultaneously on a particle are represented by two sides of a triangle taken in order, then their resultant is represented in magnitude and direction by the third side taken in opposite order. Say if you are taking a triangle, an acute triangle, say, at the base and the right hand side and the left hand side, let us take a triangle ABC. So if you have let AB be the force, first force, BC be the third force. Now A to B, B to C are the two forces here representing. Then C to A is the closing side, nothing but the third side. Now here the resultant is nothing but A to C. So this is in opposite direction. So simply it is, if two forces are acting on a particle, two coplanar concurrent forces are acting on a particle are represented in magnitude and direction by two sides of a triangle taken in order, then their resultant is represented both in magnitude and direction by the third side taken in opposite order. So the example is this. So here A and B are the two forces, the horizontal and vertical forces. So you can see the direction is towards the right hand side and it is about towards the upper side. So actually the closing side would be downwards. But here since the resultant, so the resultant has to be in the opposite direction. So again we are showing it in upward direction. Next, so polygon law of forces. So the polygon law of forces states that if any number of coplanar forces are acting on a particle are represented in magnitude and direction by the sides of a polygon taken in order, then the resultant of all the forces may be represented in magnitude and direction by the closing side of the polygon taken in opposite order. Say if you are taking six forces, so six forces means if you are representing in six forces by the sides of a polygon, then the seventh force which is taken in opposite order will define will represent the resultant. So hence here the six forces plus one, seven. So that is nothing but septagon. So similarly, if I have four forces, F1, F2, F3 and F4 are the four forces acting on a particle. Now I want to define the resultant of this. So that will be the fifth side, the closing side of the polygon. So therefore five sides, it is nothing but the pentagon. So in this way the polygon law of force will be described. So we are having one more. So here we are having one, two, three, four forces A, B, C and D are the four forces acting on a particle, a concurrent, coplanar concurrent forces. Now, so I am defining this by the four sides of a particle. Now the closing side, fifth side, represents the resultant. It is taken in opposite order. So in this class we have discussed the various things such as resolution of forces. So resolution of forces is nothing but splitting of a single force into two components, that is horizontal and vertical component. Simply we'll take if F is a force, then the horizontal component is F cos theta, the vertical component would be F sin theta. So in that manner we'll resolve the forces. And then we have discussed composition of forces. It means two or more forces are combined together to form a single force which give the effect of all the forces. Next, so this single force is nothing but resultant. So resultant is a single force which gives the effect of the all the forces. So resultant can be found in by using various techniques. So in case of collinear forces, it is simply sum of the forces if they are all acting about same direction. If they are acting away from each other in the collinear system, then the resultant would be uh, the difference between the two forces. Next, if the forces are coplanar concurrent or non-coplanar concurrent, we have parallelogram law of vector, law of forces, triangle law of forces, and polygon law of forces. In parallelogram law of forces, so we simply state a statement that we give a statement that if two forces are represented in both magnitude and direction by the two adjacent sides of a parallelogram, then the line or the resultant is represented by the diagonal passing through the point of intersection of the two adjacent sides. And in this we also derived the resultant r is equal to p square plus q square plus 2pq cos theta. And the angle made by the resultant with the horizontal alpha is equal to tan inverse of q cos of q sin alpha by p plus q cos alpha. Next, we have discussed triangle law of forces. So, triangle law of forces simply states that if two forces are represented in magnitude and direction by the two adjacent sides of a triangle, then their resultant is represented by the then their resultant is represented by the third side, that is closing side of the triangle taken in opposite direction. Next comes polygon law of forces. If number of forces are represented by the sides of a polygon, then the resultant is represented by the closing side of that particular polygon. So these are all can be used for the graphical method of finding this polygon law of vectors. We can find these forces both in graphical and analytical methods. So in the graphical method, we simply give the certain scale. Say if it is of 10 forces, we will take 1 centimeter. Likewise, we take the scale and we draw the forces for the given angles, and will continuously join one by one, and the leftover space whatever we'll get is nothing but when you join the first force, the starting point of the first force and ending point of the last force, that distance would give the resultant, and the angle made with the horizontal would give the angle made by the resultant. So in graphical method, this is the scenario. And in the analytical method, we are going to make use of uh, other formulae that we will be discussing in my next presentation. So, thank you. So, any queries, please do comment in the chat box.